So many of the things, okay, so let's go here. I'm going to hide this. And then, so I'll go to Airflow just now. Okay, you can just do a search for Airflow, but for me it goes to Airflow lib because I've gone there before. So I go to airflowlib.org. Okay, and if you, because I've used this several times, if you go to search, then it gives you this, which you can use to search for different compounds. So you can decide how many species you want in your compound. So for instance, you can say you want to. ICSD is some of the compounds in the inorganic crystal structure database. Okay, so it's not everything. And then you can say you want a compound that have boron and carbon and nitrogen. So actually I should change it to 3. So you can just do a search for this. Okay, so if you do a search, it will return different compounds. In this case, it found only 8 entries for the search that I made. You can click on each one. It's opening in a new tab. It will give you the structure, calculated structure, and different things, and you'll be able to take a look at them and use it for. You can download the structures and use it for your calculation. GFT calculation using Abinit or VASP or Quantum Espresso. So you have this. Okay? And the different structures that have B, C, and N. There's B2CN, and these are 2 different structures. Okay. There's another BC2N, sorry, BC2N, different structures, and you can look at their properties. This line that you see here will become very important soon. This line, afflux summons, will become very important soon. I'll tell you a little bit of how to do it. This, I just did a search like this. If you click here, then it allows you to add different properties that you want. Okay. If the property is not in their database for a particular compound that you want, the compound will be missing from it. So you won't get the compound. So for instance, if I say I add electronic band gap, this band gap is calculated using DFT. If I say I want band gap to be there as one of the properties that I want it to be, and then I do a search again, it may still have 8 or it may have less than 8. So I do a search, let's see. Okay, still found 8. Let me try to see. So I'm just trying to say that if there's some properties that you don't have there, then it will, okay, so let's say we ask for the Dubai temperature. Okay, we add the Dubai temperature to this and we search again. So now there are 2 entries because there are only 2 entries for which the electronic band gap type and Dubai temperature are recorded. So only those 2 entries will be shown. Okay, so I'm going to show you one thing I did to try to get do a fit to thermal conductivity. So I'm going to reset the search. Okay. Yeah, I stay with just Airflow. I won't choose any compounds. Okay. But here I'm going to tell it that I want thermal conductivities. So if I go there, I want to get the thermal conductivity. So I'll click thermal conductivity. Add. It's going to display a column for thermal conductivity. I don't restrict the values, so you can restrict it. For instance, you can say, I want things that have only high thermal conductivity, so you can decide which values you want, and it will show you those in the column. This way, I don't restrict it, so it gives me all the data. This AGL I just found is obtained from GFT calculation using some Gibbs model. Okay, so it's really not experimental. Later on, I can show you how to get some experimental thermal conductivities. Actually, not by querying a database. Okay, I'm not an expert in querying database. Gianmarco is here, and he can tell you more about how to query. So there's a database that has been already downloaded and zipped by the materials project database before. I think it's experimental, and then you can use it. One of the things I do is I cheat. I go into the code to see what is written in the code, and then I get an idea of how to do a call or Python call and things like that. So in this case, it will display the space group, Pearson symbol, which if you like, you use or you don't use, and thermal conductivity. So I'm going to search all the ICSD database. So I do a search. Okay, so it's found 5,578 entries. In the past, you can list them page by page, but now it lists only the first 1,000 entries. But it puts this afflux summons there that you can use to get as much data as you want. This is thermal conductivity at 300 Kelvin. So you can take a look at the paper that they give here. Let me go there. For how they determine the thermal conductivity. So you can take a look at this paper and they will show you how they did the calculations and determine the thermal conductivity from GFT calculations. Okay, so I'm here with this page. You'll see that there are only 5 pages. If you go, only the first 1,000 entries are displayed. How can I get the rest of the entries? 5, 5, 7, 8 entries. It turns out that this afflux summons is very important. From here, this gives you 1 to 1,000. You can see there's 1 to 1,000 here. So I'm going to copy this link and I'm going to use a command in Linux called wget. I don't know the equivalent in Windows, please forgive me. And I'm going to change this to 6,000, or if you like, you can change it to exactly 5578. So I copy the link, and my machine is, this computer is, what do you call this? It's Jekyll and Hyde. So what I mean is, it's both Windows and Linux. So I have my virtual box. So I'm going to go there. Yeah. So while it opens, do you have any questions? In the past, when I did this work with my former students, Firas, you know, here the thermal conductivity are already here in this column. So you can see this column has the thermal conductivity in watt per meter Kelvin. So what we did was to copy it, copy the page and put it in the Excel. So we just copy, like, you know, you try different things. So what we did was then we just did a copy like this, down, 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 down. I think then it could give you 1,000 page, 1,000 entries per page. You copy and then you paste it in Excel. It will ask you the formatting, you put it in, everything will be there. So this is what we did there. So these are days of like struggling, and just 2 years ago, but many things have changed now. So you see how easier it is. The other thing now is, you know, this Airflow people make it very simple. I just copy this. So I don't even know the syntax. I don't know like how to do all this. They put it there, I just copy it. It's a lazy way to do it. Please don't do it this way. Think of all what this means. Okay. Okay. So I was talking because I'm waiting for my virtual box. Okay. So I say like,
Doc.
Yeah.
Excuse me. Can you?
Yeah. Go ahead.
Sorry, Doc. I said, can you search for individual material other than the whole catalog? Is it possible?
What do you mean by
materials? I mean, searching for certain material, because I see you searching the whole catalog now for thermal conductivity.
A few minutes before, I searched for BCN.
Okay, okay.
Of D, C, and N. So if you go up here, you can do that. You can. Sorry. If you look at the search here, there's a periodic table, right? And then you can search for different species. Like you can say you want something that have only 3 species. You can choose boron, C, and N. Okay. And I'm searching only the ICSD, and you can do a search. Or if you want, you can do all of our flow. which will contain compounds that have not been synthesized also.
Mm.
So yeah, so you can do that and then click search.
Okay.
Yeah, the periodic table is there. So in this case, I'm going to copy this. So I copy link.
So for those who did the search on the query in the first project, this is just defining the criteria. So what just Omololu did to define the series of criteria and the property that you wanted. You define the property that you wanted. In this case, he didn't put any criteria because he said that it took, or you put binaries, or is it all of them?
I think all of them.
All of them.
Yeah.
So he didn't put criteria, so you can put no criteria and get everything.
Yeah. Actually, you know what I did? What I copied.
Yeah.
Okay.
It's a way to do that.
Sorry, Jamako is far from the microphone, so we can hardly hear him online.
Oh yeah, okay, no problem. When he wants to talk next, I'll let him. Okay. Okay. So I do wget and I put an apostrophe. I paste the stuff I just put and I put this. Now I will try to get the first 6,000. Okay. It will stop at 5,500 or something, but I do this. So I do the wget. I wait. You see it's downloading. So wget is a Linux command. I don't know the Windows equivalent. So I wait and it's downloading.
You can copy that link on the web page on the browser.
Oh, but then need to copy this.
Yeah, and then you save.
Okay. Yeah. Yeah. So Jamako is saying you can, if you have a Windows machine, actually, why should you use just a Windows machine? Yeah, so you can have this and then you can, ouch. I think you can save it. Yeah, you can, so you can save it. In what I've done also, you'll see that it has saved the file. That this file index.blah blah blah. Okay, I'm going to rename it. Someone said why do you rename it? Because I want to. So I'm going to move it to. Sorry, it was 6,000. I'm going to move it to thermal cond. You see, I have one already there that I did before. So let's just do it. JSON. Sorry. Let me copy the name exactly. I cheated before. So move this. Okay, so I moved it. So it's a JSON file. If you want, you can take a look at it and say, yeah. So it's a file like this. It contains the is a dictionary, Python dictionary. So
if you go on the website as you did before, it's easy to see what you get.
Oh, okay.
Yeah, so you see.
Omololu, how to do it in English in Windows?
That's what we just said.
This is what we said. So you can click the link or you can copy the link. So in this case, if you want, you can. The link, I just copied it and I pasted it here. You can change it to your first 6,000. Let's change it to the first 2,000. So it downloads everything and then you can now save it or you can copy it. So if I save it, it saves everything, right?
Can you send the link or
No,
this is the link? Upload someone's.
Oh no, you go to upload, you do your search. You do a search, and then when you do a search, I did a search just now. It listed 5,578 entries, and then I need,
yes,
but only the first 1,000 entries are displayed. So you use this upload summons to get the rest of what you want. So the reason is 1,000 entries is because it goes from 1 to 1,000. Yeah. So if you change the 1,000 to 5,000, it will change, add more. So if you click on this, or you can copy this.
I got as same as you got. Okay.
So I put it here actually, and here I change it when I did it from 1 to 2,000, 1 to 1,000. You can change it to 1 to 6,000. You wait, it's going to have everything, and then this is everything, and then you can save it. So it's still downloading actually. So you can see it's still downloading, and then you can.
So Doc, using the Linux terminal, you did get the all for the airflow, the URL for the airflow, and then when it downloads, is it downloading into a JSON file or you have to move it into a JSON file?
You downloaded it into a JSON file. Okay, so the JSON file is this one. But
Okay,
you see,
the long file.
yeah, the long name, yeah. So
Okay.
the name is too long for me.
Okay.
So I moved this somewhere to make it shorter. And then I put a JSON extension so I remember it's JSON.
Okay.
Okay. The good thing about coming to workshop and interacting with other people is, in the past, what I did was I wrote a Python script to pass the JSON and to get the information that I needed. Okay. So I think on Wednesday when I was going to do that, I was talking with Jamako and he said, oh, maybe you can just read the JSON just like you read the CSV file with pandas data frame. I'm like, okay, let me try. So I did help for the pandas and I saw that there was read JSON and I just used it and it read the JSON file. You see, how lazy can I be? Okay.
Maybe you can show again. I mean, you see here what you have is the different material that were in the database. So when you click on the triangles, as Omololu was showing,
Yeah. So when you click on the
triangle, you
triangle,
see which material it is.
okay, yeah.
You see the compound,
Give you the compound, then a flow ID,
and you have
you
all
give
the information there.
the URL, the space group, the symbol, and then the thermal conductivity. So this for the first compound, and then for the second compound is similar. So this is the second compound, G1, Ni2, ZN1. Okay. This works just for outflow. So it gives you all this, and then you can save everything. Okay.
Well, as soon as you have a JSON file, it's like that. Optimate will give you JSON file like that.
Okay. Yeah. Okay. So yes. Can I what? This is Windows, right? What do you need?
You just click on the link. Just do it. Go on the website of
So I went there.
yeah. You just click on the link.
The upload summon is there.
You just
Summon is
click
there.
on
You
the
click on this. What's your question?
Yeah.
You trying to do it?
Well, you're using a Linux machine, right?
Yeah, but this is that. This is just because we're using Google Chrome. You need to use Firefox. You see, if you use Firefox is a nice.
Oh, like this.
Yeah, there's only Firefox that does that. The other browsers they don't do that. You would get the text.
Oh, really? Okay. Yeah, so you can get the text. You can do Control A to copy.
It's the same thing, just that it's visualized better in this way.
Yeah.
If you use Firefox, it's going to be like this.
Yeah. You can do the same thing. You can use Control A to copy, right? And then you can save it. Okay. In this case, I can just save it here.
Yeah, you can save it from here, save file.
Yeah, then I can save it as.
And if you don't have Firefox, there are many JSON viewers, so you can use another JSON viewer.
So I can save it and then I can use it later on. Okay, it's like 1.2 meg. Okay, so now let's see how I read my JSON file. So at the top here, I import pandas as PD. DF is, and then I create a data frame by reading the JSON file. So actually, if you do this, I think it's DRR PD, no pandas.
Or even PD.
Maybe help pandas.
You did PD will work.
Wait, oh, okay, PD. The other thing I have to check whether okay, yeah, DRPD. So it works. So if you go in it, I looked and then I found read underscores CSV and the one I needed. Yeah, so you see there's read CSV, there's read Excel, there's read feather, and then there's my needed thing, read JSON. So I just read the JSON file.
And yesterday evening, we discovered the read pickle to dump.
Oh yeah, to dump. Oh yeah, yeah. So yeah, actually you can save the whole
data frame. So what we did yesterday, we downloaded the data frame, we dumped it to pickle, and then you can read it
Okay. So I read it, the JSON file, and I go ahead, and it shows me this information that I have here. So if you want the information, is here. So the compound 0, 1, 2, all the way down. Head will only show you the top 5. The compounds are here. The Aflo ID is there. There's a URL, there's a space group for the relaxed structure, there's a piercing symbol, and there's what I need, the thermal conductivity. Okay. So actually I don't need this. I could cut this away. You know, when I was doing it, I was trying different things. Okay. The next, so this, you have your data that you need. So each compound has a label. So the label I need is the thermal conductivity, and each compound has a label here. So the compound like BI4, the label or my target property that I want is the thermal conductivity, and is in this column. Okay. So at this point, the next thing to do actually is, you know, I told you that when you do machine learning, what you want to do is you want to express a property as a linear combination of. Sorry, let me mute everybody.
Oh.
Okay, so what I want to do now is I want to, okay, so I told you that when you want to do machine learning, you want to write the property you need as a linear, as a function, okay, good. As a function, whatever the function is, of some properties, okay. The simplest one is linear regression, where you write it as a linear combination of the properties, okay. You will see now that linear regression actually doesn't work. So the properties I need, how do I get the properties? Okay. So this, I'm going to show you some steps. This is not the best way to do it, but this is a simple way that can help you in less than an hour to get this property. So from the chemical formula, okay, I'm going to get a bunch of properties. For instance, let's look at the first one. The first one is BI4, okay? So from BI4, you can get the average ionization potential of BI4. Okay? You can get the you can get the mass, okay, or the average mass.
Radius.
Yeah, atomic radii, average atomic radii, different properties you can get. You can get the magnetic moment because each atom has a ground state magnetic moment, so you can get all those. So those are the features that you use. Okay, I think I still have my slide. So okay. So here, so you see, you have all these properties. From just the chemical formula, you can get all these properties. There are more advanced things you can do. Like if you know the structure, like the lattice constants and the positions, there are other properties that you can get, okay? I'm not going to go into that. The one that we are going to do is very simple. We're just going to use the chemical formula. And then from the chemical formula, we get a bunch of things, okay? So there's you can get the average atomic mass, the average of the covalent radii, average of the van der Waals radii, average of the ionization potential, average of the ground state moment of each atom. So each atom has a ground state moment, magnetic moment. So for instance, sodium is spin half in the ground state. Yeah, then you can, so all that information, you can use it. If I give you a compound like this, you can get all those information for this compound. If I change to another compound, which you can see here, yeah, so the main idea is now, whatever property I want, in this case, the thermal conductivity, I write it in this simplest machine learning, which is linear regression. I write it as a linear combination of all this. For the other machine learning, like random forest regression, There are other models, but they also have parameters in them. Or say neural network. Okay, neural network. Okay, there are also parameters in them. Okay, so the main thing is we want to get the parameters by training on this data that you have just downloaded. So the data we have just downloaded, they are here, and we are going to train on them. So what I'm going to do now is from this chemical formula, BI4, Hg33, RB3, Hg33K3, all of them, I'm going to get features. And those are the features that I'm going to use to do the training. Okay. So, yeah.
I also could generate the direction.
Yeah, import pandas as PD.
How do you generate that?
This one?
Yes, no, that one I asked.
So I import pandas as PD.
Yes.
DRR is just to list the
I also have
properties.
that.
Yeah, but you don't need to do it. It's just to list the properties. So you see all the methods that are in the pandas. Okay. So you don't need to do this. I do it so that I see the properties, the methods that are in it. Then I read my JSON file.
That is what I wanted to read.
Okay. But you have to, in this case, okay, put the full part of where it is there. Okay?
Yes.
You have to put the full part. This one I can do it this way because I already have it in the directory in which I'm working.
Okay.
Yes. You don't have to do a head. I do a head because I want to see what is happening. So, actually, I don't need, okay. I don't need this line from PyMagen import composition. Don't think I need it. Okay. But I need this math minor featureizers. I need this string to composition. In the data frame, when you read, in the data frame, the compound name is just a string. Okay. So this string, you need to convert it to a composition. So it needs to know that there are 6 cesium atoms and 40 mercury atoms. Here it needs to know that there are 4 silver atoms and 2 oxygen atoms. Okay. The way you do that is you use this thing, this method or this class from MathMiner. Okay. This one I don't think you need it, but you see, some will say I don't have MathMiner. You have to install MathMiner. To install MathMiner, I'll give you the command to do that. Okay. I think you see I have a factorial or shebang or exclamation. So I do pip install.
Yes.
MathMiner. Okay. And then shift enter. This exclamation point is important. The other way to do it in command line. So if you, instead of doing something in command line, you can do it in your Jupyter, but you have to put an exclamation point. The exclamation point helps you to know that you should invoke it in the shell, not just like a regular command. So I do this factorial MathMiner. You have to be connected online. It will install MathMiner, but it will install PyMagen, many other packages before finally install the MathMiner. I already did that some long time ago, so I have it.
For you guys, you can start from here exactly from the data frame that you have.
Yeah.
Because you also have the principal.
Okay, yeah. So if you've installed it before, it's fine. If you've not, then you should install it. Okay. So I'm not going to execute it because I already have it. So this line is the one that is important from MathMiner featureizer conversions, import string to composition. How did I know about this? I looked at the video from materials project, and I looked at the files. So if you look at the files, maybe not unit 3, maybe unit 2. The files you have, you see, is exactly this, not this actually. If you go up, you see how plagiaristic I am. I just copied it. You can do the same. It's not like, okay, so I copied it.
We always do that.
Yeah.
I mean, you cannot remember all the things that needs to be done. So
Yeah.
you copy or you use one of your previous notebooks. That
Exactly. Yeah. The
So
physics
isn't there a manual kind of for material projects on how to put all these what's it called, all these lines? commands.
Yeah, okay. So it's like my student asking me that, um, how would they have known this? Yes, this is the reason why you are a master's program. This is the reason why you come for the workshop. This is the reason why you watch the tutorials. Yeah, so when you watch the tutorials, they provide you with these notebooks that you can use and learn from. So you just have to learn it. They have, you can Google the manual, Math Minor manual, but the manual is dated. They wrote it some time ago and they're not updating it.
There's video online. There's a YouTube channel in the talk by Anubhav Jain.
Yeah.
He showed the link to a YouTube channel for the materials project. You can go there, and there, among others, there's the video by Alex. About this exactly, where he shows all the steps.
Yeah, so you just have to learn. If you go to the data to the manual, there's some commands that have changed, and if you keep following it, you keep having errors. Okay, so the last workshop was in 2021. The one in 2020, I think, is still useful. The one in 2021 also. So the materials are there online. I just took them. I've shared them with you. So I copied this part because I watched the video. Even this one, STC equals this. So I instantiate this class. Okay. So I create this variable if you want, which I create this object STC using this class. Okay. In fact, I use the same name. I don't change the name. So you'll see what I do here. So from math minors, featurizers, conversion, import string to composition. So I create an object STC using the string to composition. You don't have to call it STC. You can call it anything you want to. I'm too lazy to change the name. I left it there. STC equals this. Okay. Then you now call this method of STC. So STC does featurize data frame DFT. DF2 is it DF2? Oh no, it should be DF. So this should be DF, okay? DF that I have. And you can make it again into DF, but you know, I'm too afraid that I may make an error, so I make it into a different frame, in a different data frame. So I take this DF. What this is telling it is the column that has compound. Okay, so this column has compound. When you download your JSON file, instead of compound, it could be formula. Okay, but I'm wanting to use this column to get the composition. Okay? So the heading of this column is compound. For another case, it could be formula, okay, because this or chemical formula. So you just need to let it know which column to use to do the conversion. So to convert from string, which this column has, to composition. So I now do DF2 is the original data frame I have. The column I want you to use is compound column. Okay. And I run this. I think this may take some time. It takes some time. It tells you how it's progressing because it has used there are 5664. If your computer is faster, it runs faster. Like on my desktop, it runs much faster. On my other laptop, it runs even slower. Okay. Now I don't think I need this one. This one I don't think I need. Okay, so it has finished. Okay. What?
The element properties.
Okay.
28.
No, so I cheated. So I'll tell you how I cheated. So I went online and I found that okay, there's this thing called Magpie that can help you to get a lot of properties, like we mentioned. And so if you import this element property, it turns out that you can use a preset property. It doesn't have all the properties. Like I will have would I have liked something from the atomic orbitals, which it doesn't have. So maybe Gianmarco will tell us how to do it. Like if I wanted to use more properties, how would I do it?
I have to look at the notes.
Okay, yeah. So what I do now is I imported this from MathMiner. So this line also, I found it exact. This one actually, I think I found it online. And then I create a new object. This magpie, okay. Now I don't want to go into looking at the data. This magpie, you could, is a preset thing. Magpie was created by Professor Wolverton. What it does is it takes the compound. Let's see. Before then, it takes the compound, the composition, and is able from the composition to get different properties. So we'll see that just now. This DF2 that we have, let's head it and see what you have. Okay. So DF2 still looks similar to what we had before, but in addition, you will see that it has, let me go to the last column. It has added a column for composition. Yeah, so that's added a column for composition. So this is not the best way to do things. You see that the composition just tells you there's silver and there's oxygen. It doesn't tell it how many silver, how many oxygen. I don't know exactly why, okay? But we are just going to use this information to try to see how well we can reproduce the thermal conductivity. Okay? So now this is your DF2. Okay, this property. So I already created this EP featurizer. Okay, element property featurizer using Magpie. There's another one you can use. There's DEML. There's different ones you can use. I'm using Magpie because the first work I did with my student Firas, we used Magpie. So now I'm going to featurize column 2 using the composition column, not the compound column, okay, but the composition column. Okay. So I do DF3. Okay, this takes quite some time. It will take like a minute because I did it before. It took like 55 minutes. Sorry, 55 seconds. If your computer is more powerful, it will do. So it's running, it's converting the composition to different properties. Actually, because I've done it before, you will see the different properties below. There's a composition, then other properties, you have it.
Yeah, you use Magpie.
Yeah, I use Magpie.
Yeah, for the properties, Magpie is probably the best you can do.
Okay.
I mean, then its features related to the structure.
Okay. Yeah.
What is nice in Miner is that it combines everything, so you get.
Yeah.
So
Any
please,
questions?
can you ask him to be loud a bit so that we can hear too?
No, he was just talking to me.
Okay.
If he wants to talk to everybody, he will raise his voice.
Okay.
Okay. So now I'll finish this this part. So far now, really no machine learning. Okay, it's just I get my data. Okay, and then I can head it to see. You see, before I had all this column without the composition. He added the composition. Now let's head this one. Okay, so now you'll see that it has added more things. Now there are 139 columns. What could be in all these columns? So let's go up. Ouch. Sorry, I have to reduce the font size. There's the compound, there's some things, space group, person symbol, thermal conductivity is this still there, the composition is there. Okay. And then there's some things that Magpie gives to it. So for instance, there's this Magpie data minimum number. You have to read what's the Magpie manual to know what all this one is. But at least here, you see the range of the ground state magnetic moment. There are other things here that is not written. There's a way in Jupyter, if you wanted to write all the columns, there's a way to tell it to write all the columns. Yeah, judges.
Yeah. So when you featurize,
yeah.
So it will add properties related to composition by itself.
Yes. So when I do the featurize, so it adds all this column. Like this one is Magpie data. It uses This is the range of the ground state magnetic moment.
How does it give that information? How?
Because we give you the composition. You say
You have features for each element. Okay, so the atomic number, the atomic mass, the atomic radius, the electron affinity, the ionization potential, you name it, plenty of that for each element. Okay, so then you say, what is the composition? If you have 1 silicon, 2 oxygen atoms, then you can do the mean of each of the value of the elements for your structure. And so it just adds these numbers. So
Okay.
for instance, if he knows the magnetic moment for all the elements, it's easy to compute an average. It's easy to compute the standard deviation. You usually can put both the average and the standard deviation.
Yeah. I'm trying to see if I don't want to write everything on the
space group.
Yeah. Okay, so I don't want to write everything on the same line, but because okay, so let's write like
it's really properties that are related to each single element. And so based on the fraction of each element in your compound, you just do an average, and then you can compute the standard deviation. You can do anything you want with that.
So you take it from the database, this information for each element, and you combine it.
So basically, you have a series of numbers. Okay, who cares what they are, related to each element. And then when you have the fraction, you just do an average of sectors. And then you put that in the
yeah. So you understand, right?
Yes.
Yeah. So for instance, each atom has an ionization potential. So you can find the average ionization potential because it knows your composition. Okay. You can find the mean, you can find the range. Yeah. So those are the properties it's going to use. So the next thing
in other words, each line here, each of this column is the average of each of these compositions.
No, it doesn't have to be average. Sometimes is like you will see. Sorry, it could be average. It could be range. It could be standard deviation. So let me just do head. 4. So you will see just now that. Sorry, please hold on. Okay. So for instance, it uses the range of the ground state magnetic moment.
Okay.
It uses the mean of the ground state magnetic moment. It uses the average deviation. It uses the mode. Okay. So like if you have ion and you have ion and neon, okay, then it will use the ground state moment for ion. It will find in the compound, it will find the range, the mean, the average deviation, the mode. Okay. So all this information it puts there, and these are properties that it uses. There are other properties, if you want to see them, they're in between here. Okay, you see there are dots here. The next thing I'll do is I'll just do a describe. So describe tells you like how many, it tells you different, just a count. It tells you the average, the standard deviation for each of the columns. Okay. And so it shows it for each of the columns. Let me ask, does anybody remember how to show more columns? I think I wrote it to you before. Okay. Okay, but you can find how to show more columns, and then it will show more of the columns. Okay, so this is the data. Okay, if you try to fit this data, yes, you can see everything, but there are some what do you call it? There are some places where there's no information. So in the properties, there will be some that don't have information, okay? Because maybe the compound does not have an ionization potential in the database, so it won't be able to compute the ionization potential for your compound or the mean ionization potential. So there will be some places that do not have any values. So what I will do is I'm going to drop those lines. There are other ways to treat it, but I have more than 5,000 lines. I can drop the ones that, well, first I'll check if there are not too many. If there are not too many, I can drop those lines. So let's do this. So I'm going to take my DF3 now, right? I'm going to check whether something is null. If you just do this, it's null. It will write true if something is missing, and then false if it's not missing. Okay. So if you do that, it will give you this big table that has true and false. Let me try. So you see it has false, false, false because nothing is missing. And then if you keep going, you will see some true ones. Okay. I can't look through 5,000 things. Okay. So what I'm going to do is I'm going to sum every column. Okay. This one still I can't tell because you see here there are things that are missing. And then I'm also going to sum every I sum every column, and then I'm going to sum everything still. So I'm going to sum everything. Okay. So there are 12 things that are missing. So in this, do you understand? In this Excel sheet, think of this as an Excel sheet. There are different properties. There are too many. Some of them are missing. Like this one is there, but if you look, some of them are missing. Okay. I can't look through everything. So if you do is null, it tells you true if it's missing. Still, you can't look through everything. So I use sum. I sum every column. Still, I can't look at everything. Okay. Then I sum all those ones, and I see that 12 are missing. Okay. Even if all the 12 are different lines, so maximum I will lose 12 lines if I drop. Okay. I have more than 5,000 data points. I can do that. If you have 20 data points, you cannot do that. 20 data points, and then you drop 12, you cannot. There are other ways to do that. You can use maybe an average of the column and things like that. There are people that do that. So I do the simplest thing. I create a DF3, I do this. Okay, I drop all the ones that have missing elements. Okay. Then I can do the same thing again with DF4. You don't have to create another DF. You can use the other one. But I'm prone to make mistakes, so I tend to use another one as long as I have memory to handle it. So let's do the DF4 now. And yeah.
What's the function of drop?
If you drop the ones that have not a number. Not a number means it's empty.
Okay.
So if you drop those like yeah. So if you drop those ones that so let's do with DF. Yeah. Because when it's missing value, it's hard to use it in machine learning. So this is part of cleaning your data, which you should do. Yes.
Can we use the other choice of missing value instead of drop because you need more data?
Yeah. So this is what I said. So if you have like 20 lines, you don't want to drop 12 of them. So one of the things you can do is you can use there's some other functions in data frames that you can use where you take the average of the column and use it. Yeah, or you can use the mode of the column. Sometimes the column is, yeah, or you can use the mode of the column. Okay. So you can do that. So you replace the missing one by the mode of the column or by the mean of the, you can do that also. So in this case, I have more than 5,000, I can, and there are only 12 max, I can afford to drop. Yes.
You go back to the featureize command.
The what?
Featureize command.
Oh.
I'm getting an error.
Which error are you getting? Featureize?
I'm missing one position value.
Column I, no, I have DF2 here. No?
Oh.
Okay. Okay. So if I do use DF3, okay. So I created DF4 and I dropped the one that have not a number. If I do this now, DF4 now, I do it again. You see, I have 0 because I already dropped the ones that are not suitable to use in machine learning. So now I have this DF4 that I can now use in machine learning. Okay. Any questions so far? Voila, any questions?
Prof.
Yeah, because they are very.
I still have question. Yes. This is null. How do you know you have to replicate the sum twice to be able to drop all lines since we have 12 lines?
Actually, if you are matrix, you don't have to drop any, you don't have to use sum. If you are matrix, you can read everything. You can read all the lines I know. Okay, so let's do it one by one. So it's just thinking, I do is null. It gives me all this false, false, blah, blah, right?
Yeah.
For everyone. I can go through and try to look for which one is true. Okay, I can go through, try to look. I don't know. Everything seems to be false to me. So it's like nothing is missing, but this is not right.
Yeah.
Then I decide, let me sum every column. Okay. So I sum every column and it tells me this column has nothing missing, this one has nothing missing. There's some things in between. If I remember how to write everything, then I would have written the properties that are in between that are missing. Okay. And you will see that some of them will have one, some of them will have two, or different things. So still with this, I don't know which ones are missing.
Okay.
Then now I sum all these columns. So I put another sum. It sums all the column. Now I tell me there are 12 that are missing.
Mm.
So it may be the same compound that is missing 12 things. It may be, or it may be different compounds that are missing 1, 1, 1, 1. I don't know. Actually, one way you can do the number of lines I had before. Okay, let's find the number of lines. Okay, so here, so I'm going to print the number of lines of DF3 is 5564, and then I'm going to print the number of lines DF4 is 5563. So actually, that was just one line that was meeting many elements. Okay. So there was just one compound that did not have many properties that I need. So that one has been dropped.
Okay,
so now I'm going to do my machine learning now. Now this is machine learning. This one is just getting your data. If you have many students, you can give it to them to get your data for you. And then you now do the machine. So we'll do the machine learning just now. Yes, Paul.
Yes, maybe when you are working on the project, project one, and notice that you can determine, there is a way you can determine which rows to drop and which ones to replace with a mean. Maybe using box plot.
Okay. No, I think the question was, okay. Paul is asking a question about the projects that we gave to you. Homework 6 and project 1. So in there, I did not tell you whether to drop or to replace. Okay, for the missing one. This is part of what you have to think yourself. You know, should I drop the line or should I replace? So it was up to you. So now I already give you a hint. If I have a lot of data, I can drop. If I don't have a lot of data, you don't want to drop. So you have to do a replacement.
But now you have to determine whether to replace with a mean or with the.
So you choose yourself also.
If there is a way you can generate a plot which will tell you which criteria to use.
I'm not sure. I think you can generate a correlation plot. Yeah. The other thing is, so let's say the data you have is not numeric data. Let's say it's categorization, like direct, indirect, direct band gap, indirect band gap. In that case, you can't use the mean. What's the mean of indirect and direct? You can't, right? So one thing you can do is like you can use the mode, like the one that occurs the most often, just replace that. So there is a compound, you don't know if it's direct or indirect, just replace by the one that occurs the most often. So you can do that. So actually, I'm not showing you because I don't remember the syntax, but you can go at the past homework as past exercises and remember the syntax. Okay. A few more things. So now the next thing we'll do is.
Let me just say one thing.
Oh yeah.
I mean, I just was looking on the web. So everything that you did from the AFlow website can be done within MapMiner. Actually, they have a retrieval, so you can, but you have to learn how. But you can get that from MapMiner.
Okay. You need to show. Okay. If you can put it in a notebook for us, or send us
I
the
don't know
link.
how to do it. I have to find it.
Oh,
but
okay.
I've just seen that it's possible. So they have some tests on GitHub.
Okay, that's great. Yeah. So now I'm going to get my target properties. I'm going to put it in Y, and then the features I'm going to put it in X. The first time I was doing machine learning, Jamako was there. We didn't do the separation. We did the fit, perfect fit. Jamako, do you remember? We did the fit, it was perfect because what we are treating was part of the features. So it was Jamako that now found out like, oh, actually I think it was the week after that Jamako. No, we tried and Ras kept telling me perfect fit. Like what's happening? So when we had the meeting with Jamako, he said, of course, because the feature you want, the property you want to predict is part of your feature. So okay. So I'm going to now put the thermal conductivity column. I'm going to put it in Y. Okay. So now this is D4. I'm going to put it in Y. I can print D4 and do all that. So you can so let's just do D4. I think this is what I do. It gives you the columns, but you can head it also. So this is just for you to see that it truly contains what you want it to contain. What?
DF4.
Oh, sorry, DF4. Thank you. Okay. No. Sorry, it's Y. It's Y. Okay. So Y contains the label, and it contains the thermal conductivity. Then from DF4, I'm going to drop different things.
Probably need to drop some other things, given that you remember you at the very beginning you had
Yeah, I have other things I need to drop. Okay, you're right. Okay, so let's see that. So I'm going to drop a bunch of things. Let's go there. Okay.
You have to go probably to the highest DF to see what was there and that you need to.
Okay, maybe I should just head it, no? Yeah, let me head it, right? Is DF what now? It's easier to use the same thing, the same DF several times.
The first DF would be easier. Can you do just DF head?
Okay. Okay, so this one.
Yeah, first you need to do that.
Yeah, okay, so let me think.
Space group relax, or I don't know, maybe, yeah, you can keep that, that might be interesting. Space group relax.
Okay, so I'm removing the compound, okay, so now I'm going to take DF4. Let me see what is in DF4. Yeah, so I need to drop the compound. So I'm going to drop the non-numerical thing. So I'm going to drop compound. I need to drop this AUUID. Definitely, I need to drop this AGL thermal conductivity, okay, because you don't want to. Yeah, otherwise you have a perfect fit. So I drop this one because it's non-numerical. The AURL also, I drop because it's non-numerical. Oh, thank you. I drop this one. Thermal conductivity, I drop because of this reason I explained to you. You can drop other things that you want. Person symbol also, I need to drop. So you see the things that are non-numerical, I drop. I could have dropped it. Composition also I drop because it's non-numerical. The rest are numerical. Okay, I drop person symbol. And I put axis equals 1 because I want it to drop the columns, not the rows. Okay. So this will create a new.
Must it be put in the same order as the headings?
No, it doesn't have to be in the same order. Yeah. because it has a name. What?
When drop column, what use?
Yeah, this is drop column. It's going to drop because I put axis equals 1.
Okay, so there.
If you don't put axis, it's going to drop the row. Or if you want to drop the row explicitly, you can put axis equals 0. But default is axis equals 0. So I'm going to create X that has dropped everything. So I do shift enter. So I have 5 rows now and 132 columns. Sorry, I have many rows and 132 columns. The head is just showing only this part. Sorry, I don't know. I don't have 132 columns. Sorry, I should do this now. I have 5 rows and 133 columns. I have to see is there any other thing I need to drop. So I have 5 rows and 133 columns. I already dropped my conductivity. So now there are many things you could do. I try to describe it. You can if you want. You don't have to.
At this point, you're not choosing a particular administration.
No. So I'm just getting my data. I try to check whether it's not all this. Okay, you don't have to do this. Actually, let me cut it off because I'll probably send you these files. One of the things also is if you like to describe it, if you like, you don't. It's good to describe it. It's good to check whether it's no, blah, blah, do all the checks. So this one I'll cut. I'll cut this one also. Okay. Now I want to do my regression now. Now this is machine learning, finally. So first I'll do linear regression. So how did I know about this? I have this that I shared with you. So if you look at this, I just took this line from sklearn, model, blah, blah, linear regression. How simple can that be? Then the next line is I create an object from the linear regression. I prefer to use capital letters. You need to read what this normalized equals true means. So this is what I did. I copy it. You can see the same thing. I copied it. The next line, I did LR is for linear regression. Blah, blah. Yes. No. The 6 months training we had, I shared cheat sheet. I think I shared 6 cheat sheets.
Yeah, so online.
Yeah, they're available online also. Actually, the one I shared, I found out that some of them are wrong. So then during the training, we corrected. So I just put this there. I copied it, I put it there. And then, okay, let's do the simplest thing we can do. I'm going to split my data into training and test. Okay. The better way to do it is to do cross-validation. We won't do cross-validation. I'll just split into train and test. So from sklearn, I split into train and test. Okay. I do this help because I don't remember. You have to choose what fraction of training and what fraction of testing. I didn't remember, but so I have to do the help, this one. So I'll kill it, remove it now. I now remember that you choose a test size. So you do train test split, XY, test size is 0.2. Yeah.
Is there a standard percentage for test and train?
No. It's a hyperparameter. There's a default. I don't remember the default. If I do the help, then in the help there's a default, but I don't remember what the default is. Usually people will use like 20%, 25%, yeah, 28. So I use 28 here. So test size is 0.2. Okay. Random state here, I put a number. It doesn't have to be 0. You just put any integer here. The reason is because so if you run it again, it will choose the same test train split. If you don't put random state, each time you run it, it will choose a different set, and you keep getting different results. This one, maybe I should put 1 or something. I put a number there. Okay. So my X I put here, my Y I put here, and this one I put exactly here. Someone say, how do you remember all this? Look, I'm a physicist. I don't remember anything. I look here. Sorry, please hold on. I'll show you just now. I look here. Where did I see it? I look here. You see this part from sklearn import test train split, and then I copy this. This. I copy it. I use it. See, I'm not confusing. It's just you copy this, you use it. So I have it here. Okay, I remember that I should choose my test size. So this one I added. So you split your data into train, test, train, test. Even as simple as remembering whether it's train and test or test and train, I don't remember. You know, whether you put train before test or test, I don't remember. I just copy it and
That file is specific to this data,
which one?
or the file you are copying from, or is it just
No, no, it's online.
Ah.
It's not even, it's from Coding Academy. Which one? Is datacamp.com. So I get this, I split. So it splits the data. And then
So at this point, it's not making reference to the file, to the data file.
no, it does because I already have X and Y, right?
Okay, you have defined X and Y.
Here, X is DF4, but I drop all this one, and Y is DF4, and I take only the column, only this column. This is Y with only this column. So I split the X and Y into train and test. Okay. So this line that's here, line 121 does the fit. So now I've done the
Sir,
fit.
please, can I ask a question?
Yes, please.
Yeah, so what is the reasonable training size that one could choose? Can I choose up to say 90% of my data for training? Is that reasonable?
Yeah. So here I chose 80% because the test site is 0.2. That's 20% for test sites.
Okay.
So that means my training is 80%. Yeah. I think this is reasonable. There's a default, which I don't remember, but if you look in the train test, it will tell you what the default is.
And I hope it's not dependent on an algorithm you are using.
No, this is a hyperparameter. Yes, you actually should. Like I said, this is not the best way. Best way is to use cross validation, but I'm not doing that. Okay. So I do the fit.
So one more thing. The training size, should it be within the range of this random states?
No. The random state, like I said, if you don't put you put random state and you put in an integer. So I put an integer 1. What that means is if I train several times, it will take the same training set and the same test set. If you don't put this, each time you run, it will choose a different. Yeah, it will use 20%, but the 20% that you choose will be different each time you run. If you want that, you can do it. But I don't want that. I want it to be that every time, if I think again, like if I execute again, okay, if I execute it again now, it will choose the same training and the same test. Okay?
The same set of data.
Yeah.
Okay.
Yeah. But if you don't put this random state, each time it will choose some random one, 20%, 80%. Okay. And then when you calculate your RMSE to be changing each time, this one, my RMSE will be the same, whatever. So this line 121 does the fit, and the fit is done. The next thing I want to do is I'm going to take the test data and I'm going to try to predict. Okay. So now, if you look at the videos we did, there's a way to get the parameters A0, A1, A2, blah, blah, from the linear regression. I don't remember how to do it. Does anybody remember? How to get the parameters? A0, A1, A2, blah, blah. There's a way to get the parameters, okay? The parameters are in this LR or something. Maybe Ibrahim Issa may remember. There's a way to get it is in this LR. So this LR contains your A0, A1, A2, blah, blah. Okay, and then he's going to use this now.
Maybe it's LR dot A0. You can do it here, the LR.
Okay, I give it to you as an exercise to do.
In the meantime, if you want, I can help you to type what needs to be done to retrieve something from it.
Oh, okay, that would be great. Yeah. So if you do that, we'll share the notebook.
I mean, it's a few lines, but just to type it.
Oh.
Do you want me to send it by mail?
No, okay, you do it later.
Okay.
Yeah, thanks. So I've done the fit. Now my test data, I'm going to use it and make a prediction. So I call it white test prediction. And I'm going to put my test data in it and make a prediction. Also, I want to see how well it did with the training data. So I'll put the training data there and I'll use it also to make the prediction. Yes, Paul.
Yes, thank you. So at that point, maybe can we be able now to see the X train and X test?
Yeah, this is what you no, X test and X train, those are not trained. The prediction is what you want to see.
Okay.
Yeah. So I use matplotlib. Okay. There's another thing I should have imported. Import numpy as NP. You see why I need this now? I create this line space. The reason I've created it is because I needed to draw the y equals x line. Okay. I find the minimum of the y test, the maximum of the y test. I create this. Now I'm going to plot y test on the horizontal, y test the prediction on the horizontal axis. Actually, it should be the opposite. I should plot y test on the x axis and the prediction on the vertical axis. And then I'm also going to plot the line y equals x. And then I'm going to show both of them. So I do that. Okay. So this is the fit, and you can see how bad it is. This is from the test. Even if you do it from the training, I did something similar. Let me quickly copy this. Okay. From the training, I did something similar. I'll copy it and put it there. If you ask me, how did I know what to do with this? I simply looked in the stuff that I told you before. So I find the minimum, maximum, and then I do this. On the x-axis, I want the train. On the y-axis, I want the prediction. So I do this. I think I already executed this, right? Let me execute it again. This one. So I'm going to plot for the training also. And you see how bad the fit is. Okay. Now, this is just visual. I'm going to calculate the root mean square error. Okay. And then you'll see whether it's good or not. So from sklearn matrix, import mean squared error. The same way I know is I'll go here and I look here and there's mean square error and I copy this. And I copy this one also. Zero magic. So I put this here for mean square error. You can get R squared also. For the training and the prediction, I do it. I find the square root because this gives you the mean squared error. Then the square root is the RMSE. So the RMSE is 11.34. Okay. You can do a similar thing for the prediction also. So you can do the difference between the prediction and the, for the test set also. Let's do this. I think I may have it down, so I could just copy it. Let me see. No, I don't. So this is RMS test. I'll do the Y test and the Y test. And then I'll print the two RMSE. They won't be too different. Let's see. Wow, they're quite different. Yeah, the training did better than the test. Okay. Obviously, right? Okay. So now the next thing is I will use a random forest regressor. The same way I go here. Oh, no, actually here there's no random forest regressor, but you can go online to find the random forest regressor.
Yes, at that point, you defined the future and the future and the
okay. So
I want you to please explain more on when you were defining the X and Y.
Yeah, so I took the whole data. For the Y, I took only the column and image.
Okay.
For the X,
Based on what you are looking for.
yeah, because I would need thermal conductivity.
Okay.
That's my target. So all these plots
yes,
now,
the target and the features.
No, just the thermal conductivity. For Y, it's just the thermal conductivity I'm trying to predict. So here is the predicted thermal conductivity. This is the original thermal conductivity.
Okay.
Okay.
Okay, X is the original.
No. In this plot. Yeah. So this Y train contains thermal conductivity.
Okay.
And then I try to predict the thermal conductivity. This is this one. So I plot them against one another. If everything is perfect, it will, all the points will lie on the red line.
Okay. Okay, the linearity of it is.
Yeah. So the next one I do is I use the random forest regressor. You ask me how do I do random status for? It's the same reason as before. There are other things you can do in here called hyperparameters. I don't do that.
What's the difference between the 4 in random state?
You can use any number. Just put any number there. Okay. Any number is like a random seed, so you can use any number. So I do the regression. Now this one takes some more time, and I'm happy it takes more time because the results are better. So I do this. I do the train. So this takes more time than the linear regression. Yeah. So good things take time. Yeah. Nigeria, they will say something about the goose soup. Yeah. So it takes more time, more effort, more money, more energy. So it's doing, not always true. Sometimes it can be worse. But let's see what happens. Yeah. Okay. So while we're here, I think the most important thing will be learn a lot of Python, really master Python. And then these other ones, yes, you can do it, but like you say, I'm just stuck. But then the Python you have to learn. And also, you need to have a feel and get to know how to train your data, how to get your data. Which one?
The one I copied from.
Oh yeah, I think I can find. Okay, so it has finished doing the training. All these things are hyperparameters, which I didn't do anything with. I used the default. So now I do the prediction from the training set. You should do one also from the test set. And then I'll plot both of them. Oh, yeah. I should, yeah. So I'll plot both of them. Okay. This looks better, right? Let's confirm it. So let's do this because this is the training, right? Let's do the one also for the test. Test feed. And then, so I'm going to do this. And then I'm going to plot this also.
You just put them on the same line.
Yeah, I could just put them on the same. So what I just want to do is I'll copy this one because I already have this one. What?
No, but I mean, you can put it on the same. If you copy just the first line.
Yeah, Jamako, you think I'm very good? Jamako. No, I'm not good. Because then when I do that, then the lines are. Ouch, sorry.
If you just copy the first line.
Oh yeah, and then just
You just copy the first line of this one. Just copy it.
Oh, which one?
Just copy the first line, PLT scatter.
Yeah.
Copy that one.
Okay, this one?
Yeah, just the first line.
Oh, yeah, and then put it on it.
Yeah, you put it on the previous one, just above.
Oh, yeah, but then I have to change the
No,
color.
it will do that.
Yeah, but I think you have to change the color.
No, it changes by default.
Okay, let me try. Oh, yeah, thanks. I'm sorry, Jamako. I'm like, I know I tell people to test it, but then sometimes I'm too cheeky to. Okay, so one is for the test, the other is for the, yeah. So actually this line I should delete. This line I should put before. Let's put this here. And then here, we plot both of them together. Thank you, Jamako. And then we calculate the RMSE and we see whether we are truly better or not.
At this point, you have your test and train
Yeah.
data plotted.
Yes. We can plot it separately like I was trying to do. Okay, so I do this. So the trainees data, because we trained it, of course. If you've seen the exam before, you pass better. Okay. The test has 7.29 watt per meter per Kelvin. And then you can compare with
Regression.
yeah, you can compare with regression. I see that regression, if you remember the one from regression for the test, for the training, it was 16. Where do I have it? So you see that we managed to use random forest to, yeah, to bring down from 16.59 to 7 point something. So now, okay, so this is machine learning. There's another step. Unfortunately, I won't have time to show you. The other step is this. You can take all the compounds in ICSV or whichever database you have, which nobody knows the thermal conductivity. You can then you can featureize and do all this, and then you can. So when I do that, I create, let's call it Y prime. I put the Y prime in this regression, and it will predict all the. It will predict the thermal conductivity. Then you can rank that. You can sort that, and then go back to find which compound it belongs to. And then you can have the compound, and then this would be your prediction of the compound that have the highest thermal conductivity. I give that as an exercise for you to do. The reason let me stop the recording.
Perfect. Now you can start.
Okay, so we are presenting what we have done for group 4A. This first cell, we are loading the data. Firstly, we have downloaded the data from Airflow. So we downloaded the data, only the formula, the compound, and the AGL thermal conductivity. Then we load the data using the class load data frame from JSON from the MatMiner. This is the path of the data on my machine, and this is the name we have given to the data. So after loading, this is the data we have gotten. So we dropped those lines that we don't need for the prediction. These are the lines here. And then we just plot describe just to have a look on the data. And from there now we generated some futures. Before that, we convert the compound to the composition that can be used by MatMiner. So the compound here have been converted to the composition after this line. I think this is exactly what has been shown this morning. And then after that, we generated some futures, but the futures we have generated, I think they are different from what have been generated this morning. So we generated the element fraction and then some other futures, atomic orbitals. The generation is exactly the same way. We import the class, we instantiate the class, and then we featurize the whole data frame to add the features that can be gotten from the class. So for example, the atomic orbitals generates these columns, HOMO energy, the LUMO energy, and the HOMO gap. Of course, is an approximation because it's not really the HOMO and LUMO of the real material, but that will be helpful for the prediction. After generating, we have these columns of non-numerical data that will not be helpful for the machine learning. Then we dropped those columns here, and then we generated some more futures using this class band center, some other futures, T-metal fraction, and then a lot of futures from this Meredith. And after generating, then we start cleaning the data. We dropped all the line containing the not a number or the empty, and then we start the fitting. For the fitting, first we start by scaling the data. This cell number 14 here, we scale the data and then we splitted the data. After scaling and splitting the data, we tried the linear regression. The linear regression, the metric we calculated is the mean absolute error. So the mean absolute error on the training set is 5.26, and then the mean absolute error on the testing is 5.7. Of course, it's a huge error. It's not acceptable because the value of the thermal conductivity are also of disorder, and then the error is also of disorder. Definitely is not acceptable. So we tried some more models from here. So, and then use the cross validation. So as we are using the cross validation, we have not used the split as we have done there, because we only need to see the result on the whole data with the cross validation to select the best model. We use supported vector machine, and supported vector machine with different value of C. This is just a random value of C we have used. Normally, we have to optimize those hyperparameter and to see if those will improve the data, but this part has not been done in our work. Then linear regression, the neural network, MLP, and then the random forest. For these 5 models, we have printed the mean absolute error and the CV score. The CV score is based on mean absolute error also, so it's almost it's the same thing as mean absolute error here. This mean absolute error is on the whole data, while this mean absolute error is on the cross validation. So among these, if we check the cross validation, mean absolute error is the random forest is the best model. It gives 3.6, while the second model will be this supported vector machine with 3.77. And from the plot, we can also see that among these models, the random forest is the best model. But of course, even for this random forest, we can see that the error is still considerable, because 3.6 is also the order of these values. So we need to improve again more on this error. One way, because when we plot the data, we can see, for example, very few data have the thermal conductivity above 200. Maybe it's also a way to cut those values because they are out of the way. Maybe, I don't know, I'm not sure. Maybe you can correct me about this part, and then try to improve the fit with this one. Also, we have only used composition. Definitely, we need more than composition. So if we can get the features based on the structure of the material, maybe that also will improve the prediction. And lastly, the other thing is to optimize the hyperparameter that have not been done in this work. So we have stopped here. Thank you for listening.
Thank you very much. Very nice presentation. Okay, who's next? Thank you. There's another group online. Oh, this is how you sorry. Okay, perfect, great. So another group. 1A, are you ready? No. 1B. 4B. 4B. Yes. Come on. You just show us what you did.
Hey.
Just 1 minute for the group to prepare. Sorry? Stop the recording. Stop the recording for a moment.
Recording in progress.
Hello, our presentation is on predicting. I think I should. Hello? Hello? Okay. Okay, so our group is 1B, and our project is on predicting the band gap type of a semiconductor. So we use a classification model. The first step, what we did is to install PyMathGene library to connect with the material project to extract the data we want for the prediction. So this is the first cell shows what step we have followed to get PyMathGene and MathMiner. Then we query the data and we put some criteria like task ID, formula, and structure to get it, the necessary informations. So the data is shown here. As you can see, this data is the data we got it from materials project. Then we change it to data frame. And as you can see here now, we have the data in a nice format. Then we remove the data which has a missing value. For example, if you see number 18, it shows in the band gap value, no value. So we removed that using dropna. After that, we have a file without missing values. Then we save the data in pickle format. And then we access it to DF1 from the pickle. So you can see DF1 now. So this is our data. Then the next step we did is futurization. So for the futurization, we had to import strto composition from MathMiner futurizer conversion. And we use pretty formula for futurization. Actually, we added composition as one column in the data, and we use composition for futurization. So as you can see here, we added the composition at the end of the column. After that, based on the composition, we did the featurization. So for each element, it checks different properties from each element, and it combines and it adds new features to our data. So the column of our data increased significantly. So we just did describe to see some analysis on our data. Then we check if there is a missing value in our data. There is no any missing value. As you can see, the sum is 0, so there is no any missing value. Then for the target, we want to predict the band gap type. So we put a type of gap from the column to predict, and we put it as Y. So as you can see, we have Y values. Then we drop non-numerical values from the data set. And for example, like task ID, pretty formula, and structure and composition, they are removed, and we put it as X. So the X value is this one without string values. Then from scikit-learn ensemble, we import random forest classifier as our model. And we made a classification. And as you see, the value of Y is Boolean, false and true. So we had to change it to array to do the classification. So using NumPy array, we change the Y value from true, false to array, numerical array. Then we do the fitting for the classification. And we do the prediction for each X value. And as you can see, we get some predictions for the value. Yeah, so we finished the project at these steps. This was the time we had enough to do in the given time. Thank you for your attention.
Okay, go ahead.
Yeah, this is a presentation from Group A. I was asked to give the presentation. So our work here was to use machine learning to determine whether a material is a conductor or an insulator. And the names of the group members are well represented. So the first thing we did was to install Permagen, because we had a lot of issues, being that some of us had zero knowledge of machine learning and what to do. So it took us a while, but at least we broke through. So we installed Permagen, and then after Permagen, we installed MathMiner. And then we tried out some other things to retrieve data from material projects using the API, but it wasn't working, or the data we retrieved was not sufficient enough. So we tried Airflow. So what we did was to go to Airflow database, and then we searched through to get materials that because we're looking for to describe the conductor and insulator. So we looked for material with band gaps from 0 to above. So we got a database of about 60,380 thereabout. So using Wiget from the terminal, we downloaded it into a JSON file. And then from there, we used pandas to read our JSON file.
Esther, it's very small. Can you increase a bit the size of your?
Okay, thank you. Just a minute.
Press F5.
Okay. Can you see now?
No, slideshow.
Yeah, now that's much better. Perfect.
It's better now, right?
Yes, way better.
Yeah, so with pandas, we read the JSON file of the data flow of Airflow. So we got about 60,380 data. So what we did next was to featurize the composition of this data. So that's what we did. And the composition is in the next slide. I'm sorry, our work is a bit short. We didn't go further because we had so much challenge initially starting. So, but we have a way forward now, and then we intend to do our work much later. So after that, we try to see what we can do with the featurization of the compound using Magpie, sorry. So this is where we stopped so far for this group, but we intend to continue with it.
Thank you very much, Esther. I mean, it's a good start.
Thank you.
I mean,
Okay,
it's a very good
thank you.
matter now of putting together the next steps that are in the slide. Thank you very much. Can they hear you?
Good morning, everyone. Can you hear me? Hello, everyone. For our group 4B, we was just trying to use the machine learning to predict the Young's modulus of a material in order to know if it is, the material is hardest than. So we started by extracting the data from the Afro database. We just pick the features like thermoconductivity, the density, and the Young modulus. And then we imported the data by downloading we downloaded the data from the Afro by using the duplicate in the terminal. And then after getting that, we imported the data. Okay. So after importing the data, we was trying to drop the column that we don't need, such as this AULI and AUID and the other columns we don't need. So we proceed by featurizing our data in order to get, for example, if you want like a compound, like let's say like a N for nitrogen, so that if you type the compound and then bracket, you type in the name of the compound, and then it will the model, in machine learning we know what is that compound. So so we proceed by using the MagPy features in order to add some properties that we don't have from the data we downloaded on the Afro. So after that, okay, as you can see, we tried to clean our data by using Dropner to remove the empty data, empty rows with uncompleted data. Then after that, we proceed by using the linear regression. So by using this linear regression, we was trying to fit our data. First, we split data into the test side, test data and the train data. So we give a test size 0.2, which is 20% of our data, and then the train is 80% remain. So, but we use the fit to fit our data into a model. After that, we tried to visualize by using this matplotlib module, and then so from our data set, we imported from Afro. As you can see, our model was okay. So we plotted the trained data. As you can see, it is along the exact. This red line here shows the exact mean property of Young modulus we should get. Then the trained data is this one of blue, which is on which we use it to know the pattern, and then we use the test data to try to check if our model, the accuracy of our model. So we tried to check the errors from our model. As you can see from the screen, we have a 4.89. I mean the mean square error for the train data, and then the test data of 7.29.
R and the C. The R is root mean square. So here is the mean square. So you need to take the square root to get.
Yes, which is according to the sprint. Yeah, yeah. So thank you. That okay.
Yeah. So. Okay, so we okay, so thank you all very much for the nice presentation. I think that we have made good progress. So I would suggest that you maybe share your notebooks with one another in such a way that you can improve them, and don't hesitate to share the improvements with the others also. And so I hope that you enjoyed this workshop. We did our best to try to show you very good level of research, and also at the same time to have you make progress in terms of machine learning. And so I thank you very much for your participation.
Thank you, sir.
That's basically it. Have a nice continuation and see you next time. Bye.
Thank you so much, sir.